That was wonderful, thank you. Good afternoon, everybody. It's a pleasure to be addressing this distinguished audience. A personal thank you to Dr. Hall and Dr. Xenidis for the invitation. So this is going to be a bit different. We're not a large company, we're a startup, and we'll be presenting our latest product. The way the presentation is going to go is I'm going to say a few things about who we are, what we do, how we've gotten this far. Then we're going to take a deep breath and go into what our latest product is, okay? So this is the founding team. We're actually 12 now. We are a startup that began in the Aristotle University of Thessaloniki in northern Greece with the goal of working on smart cities and actually software for process optimization. We do, well, these things. Mostly we help businesses and large organizations make the most of their data, so data analytics, cut down on red tape, and of course, drastically improve productivity. We do custom solutions, so we have products. Well, on our products, we have two. One that helps cities automate their processes by actually pretty much cut down on reduce most of the paper that is used right now by doing this all electronically and through the cloud. This is an end-to-end solution, the Rhoe Municipal Assistant. And then we worked with engineering firms in Greece, and we automated the process of acquiring a permit for natural gas installations from a small house to a large facility. We have, although we're quite small, we have some R&D. In the past, we have developed smart lighting for crossings for cities, and most lately, we have this, which is what I'm going to talk about. Few words, we have gotten a few awards while we have in our short lives, few events, and a bit of media coverage. So, deep breath as we go into how we developed our latest product, what was the problem that we tried to solve, why it matters, and how it impacts the sector that we're discussing today, computing and construction. So, as you probably all know, electric vehicles have seen a meteoric rise in the recent years. That is partially driven by a very large decrease in the cost of batteries and a large increase in their density. I should note that, for example, in the last chart, Norway has been reaching heights of like 65% market share, while the rest of Europe is due to follow through the adoption curve that was mentioned earlier. So what's the problem with that? It sounds very good, actually. Well, the problem is that infrastructure does not follow the market trend. Right now, there's not enough charging stations that serve all these vehicles that are being bought. The only way for a city to plan charging stations is to go on ad hoc studies and try to do something that is not cost effective, but is policy effective. We're going to see examples later. So what we set out to do is answer a few questions. We wanted to see what happens in the EV market. We wanted to see how existing networks work, and then we wanted to define some general needs, and then we could solve these needs, like address these needs, with an effective, quick, I'm going to add, methodology for planning EVs. So examples. How does EV policy, and how does EV, of course, electric vehicles, how does EV policy and EV charging networks, how do they develop? Well, it all starts in the supranational level. So large organizations, see the UN, see the EU, well, they give direction. For example, the EU, in general, it's like the less CO2, the better. And that translates to, well, some policies at a national level. In Greece right now, that means that if you own an electric vehicle, you do not pay tax for emissions, you do not pay highway tolls, and there is no registration tax. Despite of that, well, I could have you guess how many electric vehicles there are in Greece. but I'm pretty sure you're not going to get it. It's 450. Well, so maybe it doesn't work, or maybe this is not enough. So we wanted to see what happens elsewhere and what does work. Oslo, for example, the capital of EVs, as many people say. Well, they give out 8,000 euros per year in incentives. That could be free parking, charging, free, well, highway tolls, of course, free ferry rides, whatever, pretty much everything. They have free charging stations. They have actually peppered Oslo with charging stations, not really planned, but actually put charging stations every 5 meters or so. And, well, 65% market share. That works, right? Well, it doesn't really, because it's economically unsustainable. They're giving away too much money in a policy way. They want to drive up sales, so they run a deficit. We wanted to see policies and things that work so that we could understand how to model demand. San Francisco is much, much more interesting. So what happens there is that the economy and the regulations are way more relaxed, way more lax. Pretty much, if I want to buy a charging station and put it in front of my store, or in front of your company's headquarters, or in front of my house, I can do that. And after I do that, after I buy the charging station, I can charge whatever I want for it. If I want to charge $5 per minute, I can do that. It's a free market economy, pretty much, with no regulations. That is very interesting when we come to how it affects buildings. Next, we went into, so what does Oslo and San Francisco and, well, any city in Greece have in common? Needs, we actually divided them into 3 categories. The one is consumer needs. Consumer needs is the easiest one to understand. It's, well, I want to buy a Tesla, but I want it to be cheap. The metropolitan needs are, well, the city's needs, and it's pretty much, I want people to buy Teslas because they're nice for the city, but I also don't want congestion, and I also don't want to disturb the economy. And lastly, there are environmental needs, which are, well, the less CO2, as the EU says, the better. So what did we do? Well, we set out to gather demographic data. For this study, it's from the Hellenic Statistical Authority, but it's data that is available, well, pretty much from any statistical authority of a modern country. We actually use this data. I'm going to show some examples of this to predict electric vehicle demand. Say that, hey, in 5 years, people there are going to be buying a lot of electric vehicles, but not a few districts further. And we expected it to accurately, we wanted it and expected it to accurately predict the demand. Well, the demographic data that we used was from income levels to more fun stuff, like how many buildings have parking lots. This is a result that we got, an example, let's say. This is the northern Greek city of Thessaloniki. It's where our offices are, and we wanted to model demand. So blue points are charging stations. The bars, red, yellow, green, yellow, red, and black, are the demand per 5 years. So in 5 years' time, in 10 years' time, and in 15 years' time. We were quite happy, actually, with that, because we managed to predict a high demand in the commercial center, which is right near the port, like a bit above the port. I can't point because I have no pointer, or maybe I do. Aha. So we modeled the commercial district, which had a lot of, which of course will have a lot of demand, along the metro lines and the stops, which are places where actually vehicles stop, and of course, wealthy areas of the city, like around here, and stadiums, for example. So then we could do some geometric calculations, let's say, an algorithmic magic, and actually place charging stations at a building block level. So say that this building block is going to need something. Where there? We do not know, but, well, we can say that it's there. So how do we go from, well, research to a product? Having demand and knowing demand, or being able to predict demand, and being able to place charging stations, we understood that it's a very nice way to actually do dynamic pricing. Since we can predict demand and we know where the demand is going to be, we can actually vary the prices to increase profit. Additionally, we can do real-time collection from our partners, which actually install the charging stations, and run analytics. This is something that does not only affect electricity providers, but also affects, well, car manufacturers, mobility companies, and even local retail owners, which are interested in increasing their margins and well, attracting customers. So what were our conclusions at the end of this? The EV market, as you know, is going to continue to increase. There is a distinct lack of models that we're trying to address, and the needs could vary city by city, but there are some general ones. The method applied is something that made us very happy. How does this affect the building's life cycle? Well, it's quite simple, really. When we're discussing commercial buildings, it's something that can drastically increase its economic lifetime without need for further investment. If you, in the planning process, can plan for charging stations knowing that there is going to be demand, you can then actually create a new revenue stream from these charging stations. Additionally, if we're discussing residential buildings, it's the same story. Not only can you drive up revenue growth, but you can also predict, both in the case of commercial and of course residential, that a new construction is going to need a different grid so that it can serve these charging stations. The distinguished presenter before mentioned that they can model what happens if an area has more charging stations. Well, I'm going to say that that's quite interesting, and also quite interesting is what happens if you already have a building and then try to install a high voltage charging station. Either way, though, that is what we think is very interesting in this sector. But it's not the end, of course. We want to go a bit further. We want to do a bit more case studies to have even more accurate results, because more accurate results mean more profit margin optimization. And of course, it's good to monitor the EV market and, well, try to acquire better results. Thank you very much for your attention. I would love to have a lot of questions, actually.